Hello and welcome to Bay College's Intermediate Algebra Online Lectures. This is the second part of section 5.1, dealing with rational expressions. We're going to look at multiplying and dividing rational expressions, but first we're just going to review a little bit of the basics, so something that we may already know. We know how to multiply fractions. We're going to use the same concept when it comes to rational expressions, when it deals with polynomials. Well, what we're always told to do with our fractions is reduce them. We can reduce before we multiply. As an example, 27/30ths. Maybe we recognize this. Hey, these have a common factor of 3. This fraction was not reduced. So let's reduce it right away. Well, 27 factors to 9 and 3. And 30 factors to 10 and 3. And we know any factor divided by itself is 1. So that reduced to 1. So we simplified a little bit. Now we can actually go a little bit further. And we can simplify across this multiplication symbol. Because it's multiplication, this is times that. So everything on top is a factor. This times the denominator here. Everything on the bottom is a factor. So we could just factor it down and reduce our factors before we multiply. Because honestly, who wants to multiply 15 times 30 and get a really huge number, and 8 times 27 and get a really huge number, when we can reduce and keep our numbers as small as possible? So let's look at 15. Well, I can reduce that to 3 and 5. And we go up to this 9 that we didn't cancel here. Well, that's just 3 times 3. And I like to do factor trees above and below. That's how I do it. If you choose to do it some other way, maybe write your factors out in a linear fashion, you're welcome to do that. But now I could say, well, this 3 can cancel that 3. And here I have 10, which is 2 and 5. This factor of 2, I know, can go into 8. Maybe I break this down to 4 times 2. Or I can just say, well, 2 goes into 8 4 times. No matter which way you do it, as long as you don't break any laws of math. And now we just have to reassemble it. We broke it down. Now we're going to reassemble it. And it keeps our numbers small. If we say, OK, here's a factor of 4 that didn't reduce. Here's that factor of 3 that didn't reduce. 4 times 3 is 12. Well, that's not such a bad number. And on the bottom, we have 5 that didn't cancel. And this 5 didn't cancel or reduce. So we have 5 times 5 is 25. Now, by simplifying this, breaking these numbers down into their factors and reducing, the largest number I ever had to deal with was this one that was already given to me to start with. And my multiplication remains simple. So I have 12/25 as my answer here. Now, how is division of rational expressions different? Well, hopefully we remember when we divide by a fraction, we can multiply by its reciprocal. Multiplication and division are the same operation, except they're reciprocal of each other. One builds it up, one breaks it down, but they follow all the same rules. So we can change division into multiplication by using its reciprocal. So the first thing I'm going to do is rewrite this 7/8 times 32/21. Now, 7/8, that doesn't reduce. 32 doesn't have any common factors with 21. That doesn't reduce. But now that it's multiplication, everything on top is a factor. Everything on the bottom is a factor. And I can cross simplify because they're all factors. So I can just move left to right, top to bottom, and say, hey, 7 and 21 have a common factor of 7. This one would be 3 times 7, so the 3 would remain. Here, 8 is evenly divisible into 32 4 times, or it remains the common factor of 8 simplifies, leaving me with that factor of 4. Just by reducing this now, there's no multiplication left to do. I have 4 divided by 3, or just 4/3. So hopefully we remember we're just going to multiply by its reciprocal. That's exactly what we're going to do with rational expressions. We're going to factor them. We're going to cancel when we can. If we have division, we're going to multiply by its reciprocal. So let's take a look at some multiplication examples. All right, the first one here, I have the quantity 8x cubed divided by 14x times the quantity 7 divided by 4x. So we just have these rational expressions. Well, since it's just multiplication, everything is a factor. So I can start simplifying over here, cross-simplifying because it is just multiplication. I look at this and say, hey, 8 and 14, someone didn't reduce this fraction. 8 and 14 can reduce to 4 sevenths. And we can also look at these x's. Maybe we use our rules of exponents. 3 on top, 1 on the bottom. 3 minus 1 is 2. Or we can think of it, 1x on the bottom can reduce that 1x on the top. Maybe we do it that way. And now we go to the next one. So I just reduced this one fraction. Well, now we have these factors over here as well. A 7 on the bottom can cancel a 7 on the top. Well, that's good. Don't have to deal with that number anymore. A 4 on the top can reduce a 4 on the bottom. We have 2 x's remaining on top. This is an x squared. Even though I reduced it over here, I still have 2 remaining. There's an x in the denominator over here. One of the x's can reduce the other. Now, being that everything in my denominator essentially reduced, that doesn't mean that my denominator is gone. It means it's essentially 1. Anything divided by the 1 is that number. The only factor here is x. X divided by 1 is just x. So we write it in simplest form. So all this mess that we had here actually simplified to x. No multiplication necessary in that example. Let's move down to this one right here. We have x over the quantity 7x minus 21 times x squared minus 3x divided by 5. So again, it's just a rational expression. Let's factor. So because these are polynomials, they're not just single terms. We have these sums or differences in here, so we have to use factoring. Our rules of exponents do not apply to them. So this one here, I look at it and say 7x minus 21. Well, they both have the factor of 7. So I can factor it to 7 times the quantity x minus 3. Over here, I can factor x squared minus 3x to x times x minus 3. And now I can begin to simplify. Factors on top can cancel factors on the bottom. And we see here this x minus 3 is a common factor to this x minus 3 here in the denominator. So we cancel that entire factor. Now 7, there's no 7s up here. There's no 5. There's no numbers containing those factors. We have an x and an x. Nothing else is going to cancel. So I just have to reassemble it. X times x, x squared. 7 times 5, 35. And as we can see, we can just double check, does anything else reduce here? X's do not cancel numbers, so it is what it is. We have x squared 35ths, x squared over 35. All right, we're going to look at another example. We're going to look at a few that deal with multiplication. Then we're going to look at how division is similar, and yet we have one extra step. In this example here, again, we're going to factor. And you're going to find that you're going to be factoring all semester long in this class. Factor, factor, factor. When in doubt, factor it out. A nice little rhyme, right? All right, so we factored this quantity. Well, this is just the number 11. It doesn't factor other than 1 in itself. This is 44. Well, maybe we look at that as some place to factor. That's 4 times 11. Let's go ahead and write that out. 4 times 11 are the factors of 44. Now I have an 11 on top. It can reduce to 1 with the 11 on the bottom. And this is just a binomial. It doesn't factor any further. But we can see x plus 8 as a factor can reduce the x plus 8 as a factor. What's left? Well, my denominators were both reduced to 1. So my denominator is 1. So I have x times 4 left on top. 4x over 1 is just 4x. So if we simplify our factors before we do that multiplication, it helps us come to the most simplified answer before we get into the complex stuff of having to distribute all over and then factor and reduce. You can get some really ugly numbers if you do it that way. All right, so again, we come to another example. It's multiplication of 2 rational expressions. The first thing we're going to want to do is factor. All right, I look at this and say, OK, what are the factors of 18 that have a difference of 11? Well, since it's kind of a reverse FOIL applies here, the factors of positive 18 that have a difference of 11, well, I know that they have to have the same sign. A negative times a negative is a positive, or a positive times a positive is a negative. But this tells me their sign. They have to be negative. I know 9 times 2 is 18. And I know negative 9 and negative 2 would sum to that negative 11. So I can say x minus 9, x minus 2. And just to check my work, I could FOIL it back out. X times x is x squared. Negative 2x and negative 9x is negative 11x. Negative 9 times negative 2 is 18. So I check that. Now we can look at this and say, well, what are the factors of negative 36 that maybe have a difference of 5? Well, 6 times 6 is 36, but 6 does not have a difference of 5, obviously, 6 and 6. So maybe it's 2 other factors. Maybe it's 9 and 4. 9 and 4 have a difference of 5, so I'm ready to factor this. I know it's going to be 9 and 4, but which one's which? To be negative, one of them has to be positive, one of them has to be negative, but they sum to a negative. This one tells me the larger value must have been negative, because negative 9x's and positive 4x's will give me that negative 5x. So I can FOIL this out and make sure it works. Now we're ready to simplify. We've factored everything we can. Nothing over here factors. These are as simplified terms as they get. But look here, x minus 9 over x minus 9. Within its own fraction here, it could be reduced. So we've reduced that. And now we can go on to this one and say, OK, I have a factor of x plus 4, because that is being multiplied. X plus 4 is in the denominator. They reduce. And nothing else is going to reduce here. There's no x on top that can reduce this, because that is not a factor. That's a term, x minus 2. So we continue over here. X minus 2 over x is our simplified expression. All right, we're going to look at one more multiplication example, and then we're going to move on to some division. This is our last multiplication, and hopefully we look at this and say, you know what? I recognize this as something special. This is x squared minus 49. I look at 49 and I try to identify it right away as a perfect square. So what I have here is the difference of squares. And hopefully we remember from factoring, the difference of squares always factors to x plus the square root of that number and x minus the square root of that number. Order really doesn't matter. You could have x minus 7, x plus 7, but I like to be positive, put that first. So I have x plus 7, x minus 7. And now we look, nothing else is going to factor, so let's start simplifying our expressions by canceling common factors. Well, if I start top to bottom, left to right, I have an x here. That can reduce that x there. I have an x plus 7 here. That can reduce the x plus 7 there. And there's nothing else that's going to cancel. I have 2 over x minus 7. That is the simplified version of this multiplication. Now, how is division different? We still want to do the first thing, and maybe that's to factor. Factor, factor, factor. So here, this one's already factored for us to some extent. And this one here, well, maybe we can factor it a little bit more. We can factor a 2 out of here. So I'm just going to do that. 2 times x minus 9. This as a quantity. And we can see, OK, if I distribute that, yep, I get back to 2x minus 18. Now, what can I do here? Can I cancel these 9s? No, because this is a term. This is its factor. We can only cancel factors. So I can't do that. So make sure you're not doing that. Now, how is this different than multiplication? Well, this division says we need to multiply by the reciprocal. And it's always good to rewrite the problem by flipping this after you've factored it. But for time's sake, I'm just going to bring this down here and bring this up here. That is my reciprocal. So now I can maybe denote that I flipped it, and this is now multiplication. OK? So now we can start to reduce. And I did this. I know this might be a little confusing. You know, you can find me during my office hours. I'll explain this a little more. It's for board space, because I do have all the examples on here. Now we can start simplifying. Now that I've taken its reciprocal, I have a 9 on top, a 3 on the bottom. Maybe I say, hey, that 3 goes into that 9 3 times. I have an x on the bottom. Well, that can go into that x amount of times, right? I have an x minus 9 here. Let's simplify that with this x minus 9 here. And let's see, well, what is left here? Well, we have a 3 and an x, and we have this x minus 12. So I'm just going to write it right here in this board space here. I have 3x times the quantity, x minus 12. And that is my numerator. And in the denominator, well, everything's simplified except for this 2. So it's all of this over 2. So we simplified to something of a more simple nature. We don't have as much action going on here. As you can see here, there was a lot of action. We had to multiply by the reciprocal. In the next example, I have a little bit more board space. I'll actually rewrite it showing that change from division to multiplication. In this example, the first thing I'm going to do is I'm going to factor. I look at this and I recognize it as the difference of two squares. A plus b, a minus b, right? Different signs for the difference of squares. And I can say, hey, this reduces already. A plus b over a plus b. So essentially, this is a minus b over 1. Now this, well, maybe we can factor a little bit here. I can factor an a out of these, and that leaves me with a minus b. I cannot cancel these because this is division. We have to, once we simplify it, we have to rewrite it. A minus b over 1, that's my first term after I've simplified it, times, because a plus b over a plus b reduces to 1. There's still a 1 in the denominator. So I'm leaving it like this for just so we can follow, times the reciprocal. Well, this on top needs to be on the bottom because we're changing division to multiplication. And this on the bottom goes on top. Now, one thing I could have done, but I failed to do so, is reduce here. Well, I can still do that now if I didn't do it then. Well, this a can reduce that a. So we simplified it a little more. Now, everything that can cancel has canceled. So now I just have to multiply. A minus b as a quantity is multiplied by a minus b. So these two terms multiplied together gives me a minus b squared. And 1 times 2, well, that's just 2. I could also write this as 1/2 the quantity a minus b squared. Or we can leave it just like that. Either one is fine. Let's look at this one here. This doesn't factor, but just like we had seen in the previous video, this is not in descending order. And if I put it in descending order, the x term first, it's going to be negative x, positive 6. Let's factor out a negative 1 and put it in descending order at the same time. Negative 1 changes the signs, and I can change the order. So I change the sign and the order by factoring out negative 1. Let's factor this portion here. Well, I look at this and say, well, this coefficient is 1, so I just have to look at my c term if we remember our quadratic form here. What are the factors of negative 14 that combine to give me negative 5? Well, that would be x minus 7, x plus 2. Negative 7 times 2 is negative 14. Negative 7x's and positive 2x's is negative 5x's. So we've factored that. And we could do the same thing down here. What are the factors of negative 12 that combine to give me negative 4x? Well, the factors of negative 12 that have a difference of 4 would be x minus 6 and x plus 2. Negative 6 times 2 is negative 12. Negative 6x's and positive 2x's is negative 4x's. Now that I've factored everything I can factor, maybe I want to check to see if anything reduces. Hey, x plus 2 over x plus 2, that reduces. I can't cross-reduce here yet because that's division. Now that I've just simplified this fraction, now I can multiply by its reciprocal. And I'm going to rewrite that here. We have x plus 2 over negative 1 times x minus 6. That's this first fraction. Change this to multiplication, and now we're going to take the reciprocal. And I have this x minus 7. I have to put it on the bottom. And I have this x minus 6. I can put that on the top. And now we're ready to simplify further. We can cross-simplify once we've rewritten it. So x minus 6 is a quantity. X minus 6 is a quantity in the denominator. We can simplify those. We still have that negative 1. And now, well, nothing else is going to cancel. Maybe I want to distribute that negative through here. Maybe I want to distribute that negative through here. Either one is acceptable for me. I'm going to distribute it through the top, and I get negative x minus 2 over x minus 7. Now, sometimes when we simplify rational expressions, we don't all come to the same answer. It doesn't look the same. But algebraically, it might be the same whether you distributed that negative through the bottom or through the top. You're going to get the same result. Okay? It just may not look the same depending on what method you took or how you represented your last answer. Now we're going to see a place in the real world where this concept is very applicable. We have unit conversions. We're going to see this is a way to represent our rational expressions, and we can convert things from feet to yards or from feet to miles, or maybe you enjoy the metric system much like I do. Maybe you want to go from meters to kilometers or what have you. So here are some conversions. 3 feet equals 1 yard. What does that really truly mean? Well, to use it as a unit conversion, we have to represent it as a rational expression. There are 3 feet per 1 yard, which is the same as 1 yard for every 3 feet. Because what this says is this is equal to this. So it's saying a number divided by itself is 1. This is that same number divided by itself. It's still 1. 1 equals 1. So no matter which way we represent it, it's a true statement. So we can actually use this to do unit conversions, to change things from feet to yards. So let's look at this first one here. We have 10 feet equals how many yards? So what we want to know is how many yards is 10 feet? Well, we can set this up as a rational expression. If I have 10 feet, I'm going to multiply it by 1, a special 1. But I'm thinking I want units to cancel. We can treat units just like we've treated numbers or variables. What I have on top will cancel what's on the bottom. So let's go ahead and say, OK, if I multiply this by the rational expression, I can determine which one I'm going to use by saying, I have feet, but I want yards. So the feet need to cancel. If I put feet in the denominator, 1 yard per 3 feet. I will get my feet to cancel. And then we can just go on with the math. We can multiply these once I've simplified or canceled common factors. Well, the common factor in this case is the feet. 10 times 1 yard over 3, or 10 times 1/3, is 10 thirds. What's the only unit that didn't cancel? That unit still remains. And that's yards. Now, I could write this as a mixed number, or I could leave it as an improper fraction. Either one's acceptable, 10 thirds or 3 1/3. That is the answer. There are 3 1/3 yards in 10 feet. What if we were asked to convert miles to feet? Well, we can do the same thing. If we know there are 5,280 feet for 1 mile, I can use 2 different conversions. I can say, well, there are 5,280 feet per 1 mile. And that's the same as saying there is 1 mile for every 5,280 feet. So either one I can use to convert miles to feet. Well, let's look at this. If I have miles and I want feet, I need the unit of miles to cancel. So I'm going to multiply this by this factor of 1, because a number divided by itself, if they're equal, they're the same number. They're just represented differently. So I want my miles to cancel. I'm going to use this one because the miles are in the denominator. So I'm going to say 5,280 feet for every 1 mile. And now we can look at it and treat it like a rational expression. Miles, just like a variable, will cancel miles. Right? Miles over miles is 1. 1 times anything doesn't change it. And now I have 2 times 5,280 feet. Well, we can deal with the numbers. 2 times 5,280 is 10,560. And the only unit left is feet. So we converted miles to feet. The last example we're going to look at is, what if we're given units of 10 feet per second? Well, now we have units on top and units on the bottom, and we're asked to convert that to miles per hour. And maybe you remember MPH, right? Miles per hour. Just a different way to illustrate it here. Miles on top, hours on the bottom. So we not only have to convert feet to miles, we also have to convert seconds to hours. Well, we can set this up as a series of multiplication and division of rational expressions. So I'm going to start right here. 10 feet per 1 second. Well, what do I know? Well, we can use something we have here, right? I know feet to miles. Well, that's one of these conversions right here. Well, I want my feet to cancel. This one has the feet in the denominator. So we're going to say, well, there is 1 mile for every 5,280 feet. Well, that's going to change my feet to miles. So we've done that. Feet to miles. Feet are going to cancel. So the only units left are miles over seconds. Well, I need seconds to be hours. Well, you can do this a number of different ways. You can say, well, if there are 60 seconds in a minute and 60 minutes in an hour, this is dimensional analysis. We can look at it and say unit conversion. I'm converting seconds to minutes. And then I can convert minutes to hours. Maybe you want to combine it into one step and say 60 times 60 is 3,600. There are 3,600 seconds in 1 hour. Here's a conversion that hopefully you bring to the table, because we didn't show you that conversion. But hopefully we all know that there are 60 seconds in a minute and 60 minutes in an hour, and we could do that as a multi-step unit conversion, but this would result in the same thing. So to save board space, we'll just do that right there. And we can reduce seconds and seconds, just like our rational expressions. We can treat our units like numbers and simplify them. Now it's time to do the math, and we have 10 times 3,600 on top and 5,280 on the bottom. Well, these are huge numbers, right? If I write it out, I get 36,000 over 5,280, and my units are miles on top and hours on the bottom. Now, if you left your answer like this, if you were in a physics class or any other class, your instructor is going to deduct some points for this, because you have to reduce, right? Even your fractions, that applies to your units as well. So let's just reduce. We could see, oh, a common factor of 10. If you don't see any other factors, take it one step at a time. Break it down. Let's say they're both even numbers. So I can break it down by 2. I can say, well, this is going to be 1,800 miles. And half of this, that factor of 2, is going to be, let's see, 4. Oh, sorry. See, even instructors make mistakes there. 264 hours. Well, guess what? It's still not reduced. Maybe our instructor in this particular class says, this is not a calculator problem. You must do it without a calculator. Break it down step by step, one piece at a time. So maybe I go even further and say, well, half of 1,800 is 900. Half of this is 132. Look at, we're getting closer and closer as we reduce until we'll finally get to the most simplified answer. Again, it's still divisible by 2. Now, I know this is long-winded and whatnot, but hopefully we see, we get the gist of it. And this would be 66. So we keep continuing. We're reducing, reducing, reducing. 450 is still, and we get 33. Well, I've run out of 2's. This is no longer an even number. What can I do? Well, let's try another number. I know this is divisible by 3. Maybe this is divisible by 3. And it is. So we could say, okay, well, this is the same as 3 and 75. And this is the same as 3 times 11. Well, good news. We finally got to a prime number. So we can just write our answer as 75/11 miles per hour, MPHs. All right? Now, forgive me for this, but break it down, keep it simple. We only divided by 2's and 3's. I just wanted to really illustrate how we can use this simplification of rational expressions even with our numbers. this applies. And if you use it all the time, eventually it'll become second nature and you won't actually have to go through all these steps. You'll see these factors. You're going to see that, yeah, it's divisible by 2 again and again and again. So maybe we want to try 8 to begin with. So this concludes the multiplication and division of rational expressions for 5.1. Thank you for watching.